Okay, this is to help you through home quiz 2-3 here. All right, first one, we got sort of a complicated identity here now, just to kind of clear up maybe some confusion about it. They're using the variable alpha and beta there. Now, first thing here, let's try to attack this from looking at the last step. Now, there's going to be something here I'm going to do to hopefully help you see something a little bit better with this one. All right, but let's notice the last step on choice A, and let's see if we can maybe find anything that would be wrong with that. So for some reason here, they're coming out with tangent alpha times sine beta, and I'm not sure where that's coming from here, but let's see if we can take a look and find anything. And so basically it's just this somehow comes out, and somehow this would cancel out. Okay, so let's see if we can make that work there. I'm not sure if that's going to work or not, but let's try and see what they're doing there. All right, so I can tell what they're doing there is they're multiplying here by the reciprocal, and no, that's not going to work here, because what they're saying is that basically that this and this are the same thing, and they're not. They're reciprocals of each other here. So what they're doing is they're saying that that would cancel out, and that's not true here. So that's no on choice A. All right, now let's look on choice B. Now in this case, we've got something here. All right, in this case, we've got tangent alpha sine beta there just the same. And so basically they're saying that this would sort of go away, and then that would actually work. Okay, so let me give you a little explanation behind that. And so what I'm going to do is make it look more like a complex fraction by taking this and writing it over 1. So I would have tangent alpha plus sine beta over 1 over sine beta plus tangent alpha over, let's see, tangent alpha sine beta. Okay, so I want you to notice here, tangent alpha and plus sine beta is the same thing as sine beta plus tangent alpha. So that means that we can cancel those out there. So this would cancel. And so now that would leave me with 1 over tangent alpha sine beta. Okay, and now notice how this works out. We would multiply by the reciprocal here. So we would say 1 times the reciprocal. Well, the reciprocal there of tangent alpha of 1 over tangent alpha sine beta would be tangent alpha sine beta. So that one looks okay. All right, now let's look at the last step. Let's see if maybe they have the same thing there. All right, they do. They do have the same thing. I'm just making sure. All right, yeah, choice C, the last step is the same. So we've narrowed it down to choice B and choice C. All right, so let's see if we can go now to the first steps. All right, so in this first step here, I'm actually going to look at this one first. All right, it appears here that they wrote cotangent of alpha as 1 over tangent. So is that true? Yes, that's true. And then cosecant of beta, they've written as 1 over sine. So that's true. But then we've got tangent here switching to cotangent, and sine switching to cosecant. So it looks like they tried to do something there with the reciprocals, but this should have been, instead of cotangent right there, it should have been 1 over cotangent, And instead of cosecant, it should have been 1 over cosecant. So if they were going to do that, it should have looked like that. All right, so choice B is wrong. And so now it's got to be choice A. Let's just see what they did in choice A. And so they did the same thing here. 1 over tangent is cotangent. 1 over sine is cosecant. And then they just brought these over. Okay, now just to see, you can kind of see what they're doing from here to here. From right there to right there, all they're doing is getting a common denominator and combining these two fractions together. And so when they do that, they're going to get sine beta tangent alpha over tangent alpha sine beta. All right, so that answer was C. Okay, now this one looks more like a graphing question here. It says determine the amplitude and period of the following function without graphing. Okay, so let's kind of go over our equation here. So we have y equals, I'm going to use sine in this case, times the sine of wx, and then minus phi plus, I think they put b on the end there. Okay, so let's just review a few things here before we just go into this problem. All right, so let's start off and let's notice this, that the absolute value of A is the amplitude. All right, the period, the way I found the period, that's the number, how long it takes to make a cycle. In the case of sine, cosine, secant, and cosecant, we would do 2 pi over omega. And of course, if it was tangent or cotangent, it would just be pi over omega. And then the phase shift, now pay really close attention to phase shift. A lot of you guys are sort of missing the boat on this. Look at the formula. The formula right here has a negative, but yet the phase shift is just phi over rho. And so notice here that when you do the phase shift, you take the opposite of whatever that variable phi represents. And then, of course, the vertical shift is just the b. All right. Now, let's take a look and answer this question. All right, so the amplitude, that's pretty simple there. Now, it's not going to be negative 4/7 though. So that would just be 4/7 because I'm going to take the absolute value. Now, this is for the function for the given value of omega. What is the period t there? So the omega there is just 9/7. And now for the period, all right, for the sine function, the period is 2 pi over omega. So the period is going to be equal to 2 pi divided by 9/7, which would be 2 pi times the reciprocal of 9/7, which would be 7/9. And so this would be 14 pi over 9 there. Okay, next one, we've got a graph here. Let me blow this up a little bit. Okay, so we're going to graph 5 times the secant of 1/7 x. Now, first here, let's establish what the period is. Okay, so the period is equal to 2 pi divided by omega. Omega there is 1/7. So this would be equal to 2 pi times 7, which would be 14 pi. And so 14 pi is what's it going to take to make a full cycle. Now, let's do the graph. And remember, what we're going to count by here is we're going to take the period and we're going to divide it by 4. Now, we could do it this way. I think this way would be a little bit easier. So we're going to start with 14 pi. And now we're going to separate it into 4 things here. So I'm going to divide it in half and then divide it in half again. So halfway would be 7 pi. And then half a halfway would be 7 pi over 2. So you're counting by 7 pi over 2. So 7 pi over 2, 14 pi over 2, and then this one would be 21 pi. I can't even write it. 21 pi over 2. All right, now let's think. How do we do the secant functions? It looks like a bunch of parabolas. Well, the idea is you want to graph cosine here first. You want to dot in a cosine. Now, notice the amplitude here was 5. So we'll put a 5 and a 5 there. And so now all we have to do is just dot in a cosine. So remember, cosine would start up and go down. All right. Now, that's the cosine graph. Now, let's sketch in the secant. So now, you remember secant is going to be undefined where cosine is 0. So cosine is 0 here and here. So those are going to be my asymptotes. And now from our min and max points here, we're going to chase. So that one's going to chase up that way. This one's going to chase down this way. And then this one's going to chase this way. Okay? Now, let's see if we can figure out which graph here is correct. All right, notice all of them have the period set at 14 pi. Okay, so it's a matter of figuring out maybe where the asymptotes are. So let's start over here with this graph. Okay, we got the origin here. And so this would be their 7 pi. And of course, this one would be the 7 pi over 2. So the asymptotes are correct there. But let's kind of compare it to my graph. On the y-axis here on my graph, I have one right there. And so that's not it. Okay, same thing. So I believe they've put the asymptotes almost correctly in each one of them. Well, they didn't do it on this one. I'm sorry. This one down here, notice this would be 7 pi right there. And they've got an asymptote at 7 pi. And so at 7 pi, clearly here that's wrong. So I think what would happen there is that would be cosecant on that one. Now, our next one, same thing here. They've got an asymptote at 7 pi. So that's not going to work. So I guess by elimination, it's got to be the last one. Now let's check it to see. So this is 7 pi because it's half of 14 pi there. So they don't have the asymptote there. They have the asymptote where they should be at 7 pi over 2. And let's see, I've got that. Okay, notice my graph only goes one cycle here. And so that's pretty much what I've got there. Okay, so we're looking at this one here. This is our correct choice. Now, for the next one here, what I'm going to do is copy this graph so we can find the domain and range. So when we find the domain and range, what we want to do is look at our correct choice for our graph. So let me copy it. Or, of course, you could look at your sketch. Probably the sketch would actually be better. Let me paste it. And let's blow it up here. All right. So I left off the range or the domain question. Or excuse me, I'll get it right in a second. The range question, but we'll look at that. Now, let's take a look and let's figure out, well, what's the domain? Well, let's look where it's undefined at. Okay, so recall, this is where the numbers on the graph are so important. This was 7 pi, and then this value was 7 pi over 2. And recall this value here, so we were doing by 7 pi over 2, so 7 pi over 2, 14 pi over 2, so this one would be 21 pi over 2. And so let's notice here, where is it undefined? And that's going to restrict my domain. So we're undefined at 7 pi over 2. We're also undefined at 21 pi over 2. So let's notice it's not every multiple of 7 over 2, but it would be, let me think about that. So 7 pi over 2, the next multiple would be 14 pi over 2. So it's not every multiple, but it's every other multiple. And so that's where it would be k over 7, where k is an odd integer. See, or back up, I'm sorry, 7 over 2, where k is an odd integer. Now, probably what they would do is give you that same choice where they would just say k is an integer, but it's every other integer there, so it would be every odd integer. Now, the range on this, pretty simple to do the range. All right, notice you don't have anything in this area here. So recall the amplitude was 5, that was -5, and so that was +5. So the range here would be for all x such that x is less than or equal to -5, or x is greater than or equal to +5. Okay, I think they would do it in that set notation. Of course, if I were doing it, I would probably do that in interval notation. Now, let's go on. All right, find the exact value here. So let's just notice, all we have to really worry about this when we have inverse tangent inside here is about this value. So let's recall some things about the domains of our inverse functions, just as a review here. So if I do inverse sine of something, or inverse cosine of something, or inverse tangent of something. So let's look at our possibilities here. So for the domain, for sine and cosine, that has to fall in between -1 and +1. For tangent, it's all reals. Okay, now we've got the value there of 14, and that's okay. So these would just cancel out, and my answer would be 14. Now, let's look at this problem though. All right, what if this was the sine of the inverse sine of 14? Okay, so let's ask the question, would that equal 14? All right, so the answer here would be definitely not here, because this argument there of 14 is not in between -1 and 1. Now, if you want to check this, take your calculator and punch in inverse sine of 14, and it's going to tell you there's an error there. All right, so in this case, this would be no solution, or it wouldn't exist. All right, got another graphing one. Now, this one's probably a little bit easier one. I'm not really going to sketch the graph on this one. Now, I am going to find the period though. So, and let's figure out probably here what we need to count by probably here too. So let's see, the period would be equal to 2 pi over omega, which is 1/3. So this will give me 2 pi times 3, which would be 6 pi. So it should take a full cycle here to go to 6 pi. So notice this choice here, the full cycle would stop right there at 4 pi. So they're showing that the period of that function there is 4 pi. Well, that's not right. Okay, let's try another one over here. So in this case, let's see, the cycle would end right there at 6 pi. So that's not working. All right, let's see if the next one will work here. All right, this one's going up, and then the cycle stops right there. Now that seems to be okay. All right, and on my next one, let's see if this one works out. And so this one makes a full cycle at, well, 6 pi. So wait a minute, I was thinking the period was 4 pi. Let me think about that just a minute. So I'm sorry. That first one made me think that the period was 4 pi and it was 6 pi. So let's go back. So that one is okay. This one is not, because they've got it at 4 pi. And then this one is because they've got the cycle ending at 6 pi. So I have to choose in between this one and this one. And so by the way the curve looks is what's going to tell me that. It's a sine graph, so in the beginning it should start at the origin and go up, not start at whatever that value is there 2 and go down. So it would have to be this one. And there again, that's probably the only case where I'm going to tell you that it's okay probably not to sketch the graph. A simple sine or a cosine graph, you're going to be able to pick the graph. Now anything other than that, you guys need to draw the sketch yourself. Okay, now this one that says we're going to find the exact value here. So we're doing the tangent of the inverse sine of 2/5. Now, the problem is we got to think, well, where is the sine 2/5? And the answer to that is I don't know. Okay, because that's not on my unit circle here. That's not a ratio that I know. Now, if it would have given me 1/2 or square root of 2 over 2 or square root of 3 over 2 or 1 or 0, then I would know what that would be. But I don't know if it's 2/5, so you got to tell yourself here, when I don't know this, then I have to draw a triangle. Now, we've got that it's positive, and so that means it's going to be in the first quadrant. So we're going to draw a triangle in the first quadrant here. And so what we're going to let this here be is an angle theta. And so that means the sine of some angle theta would be 2/5. So the sine of this angle is 2 over 5. And sine is opposite over hypotenuse. Now let's find the other leg. So I'd say 25 minus 4 here would be 21. And then the square root there would give me square root of 21. Now I can find the tangent of theta. Tangent is opposite over adjacent, so that would be 2 over square root of 21, which would rationalize to 2 square root of 21 over 21. Okay, so there again, when I have inverse sine here and I don't know where that value is on my unit circle, I can draw a triangle. Okay, next one, we got another graph one here. So we have to graph cosine of negative 5x. Now you got to be really, really careful with that. So let's recall our even odd properties here. Say that if we have cosine of negative x, then that's just equal to cosine of x, because we had cosine was an even function there. And so before I even start graphing or finding the period and so forth, I'm going to rewrite this as just y equals cosine 5x. Now, let's calculate what the period would be. So the period is 2 pi divided by omega. And so the period there is going to be 2 pi over 5. So let's see if we can eliminate some things here. This is a simple cosine one, so I'm not going to draw the sketch. All right, so let's notice on this one, starting there, and let's say it goes from here to here. Now it's made a full cycle, and sure enough, that's okay. That's 2 pi over 5, so that makes sense. Now this one's doing a full cycle here, stops right there. Now they've got 10 pi right there, and so the period is definitely not 10 pi, so he can go to the house. Now let's look at the next one. Next one also does a full cycle at 2 pi over 5. So I'm left to decide. Now, the decision is going to be noticed that this one started at the origin and went down. This one started up at 1 and went downwards there. And I think I've left off a graph because the correct graph's not there. Let me see if I can recover it real quick. Okay, so let's look at this again. I kind of got confused there just a second. All right, notice it's a cosine graph. I got distracted there by that negative, thinking it should have started at negative, the -1 value, but it's not here because that would just change to just cosine. And so it should start there at 1 and then go down from there. And so that would be right because that's cosine. Notice what's wrong here with this one. Over here, this one would actually be the negative sine graph of that. That would be actually sine of -5x right there. Okay, now it wants us to find the domain and range here of that. So when I look at the graph to do that, so notice here when we would pass a line through here from left to right here, that the domain would be all reals, and then the range here, notice the range is definitely not all reals. The range only goes from -1 to +1. Now, Let's look at the next one. Okay, another graphing question. So this is use the graph to determine, oh, that was actually what I just answered. Okay, so I've already done that. All right, another graphing one. Now we got to do y equals 3 tangent x. Now I'm going to be careful on tangents. We need to be drawing these. Now let's find out here. The period here would be pi over omega. Now omega here is just the 1, so the period is just going to be pi. Now remember, when I sketch my tangent graphs, I'm going to offset it a little bit. And so if I'm counting by, or if my period is pi, then I would be counting by pi over 4. So it would be pi over 4, and then 2 pi over 4 would be pi over 2. And I'm going to offset and go this way. So notice the complete cycle from here to here, that does give me a period of pi there. All right, notice the amplitude is 3. So we got -3 to +3. Now we got to remember what tangent looks like. So we're undefined on both ends, and tangent is John Travolta with his right hand up. So it'd be something like that, and then something like that. Okay, now, so let's see if we can choose the correct graph here. So what I'm really going to use here is probably, again, the direction, the right hand up, and what the period should be. Now, if you notice on our first choice over here, the left hand's up here, that would probably be like cotangent, or maybe -3 tangent, I think is what that one actually graphs there. So that's not working out. Now, let's look at this one down here. And so notice that's got the right shape. Now, let's look at the values. Now, it's kind of hard to see here, but they have this value right there. They have 2 pi. And so if we take half of that for right there, that means that that value there would be pi. And if I look at my graph here, that really doesn't make sense with that, because my asymptote is at pi over 2 and theirs is at pi. So that doesn't work out too well. Now, let's look at the next ones on those there. Okay, now if we look at the second one, they've also got 2 pi there. And so notice halfway here would give me pi. And then halfway from the origin there would be pi over 2. Okay, so that one makes a little bit more sense. They've got the asymptotes there in the correct spot. Now, let's notice here the amplitude was 3, okay? And so they've got, this is 6 right there, so that would be 3, and then that would be -3. So it looks like that graph makes sense. Let's look at the last graph just to be sure here. Of course, that one didn't make sense. The asymptotes are in the wrong spot there. All right, on my last graph, well, they've got there, that's 1, and so it looks like their amplitude there would be like at a half. And so that's not working out here. It's going to be this graph. Now I'm going to copy that and use it to answer the questions here for the domain and range. Okay, and let me blow it up for you here. All right, so recall that was 2 pi. And so halfway there, that's going to be at pi. And so halfway again would make this one be pi over 2. So you've got an asymptote there at pi over 2. And so let's notice this one would be -pi over 2. And so to answer the question for the domain, all right, what's the domain of the function? Well, it's everything except for certain multiples of pi over 2. So you got -pi over 2, pi over 2. Now let's see, if is that every multiple or every odd multiple? Well, 0 would be a multiple, because 0 times pi over 2 is 0. So but it's not an asymptote at 0. So it must be every other multiple of pi over 2, or the odd multiples of pi over 2, is where that it's undefined. So that would be choice A. Now I left off the range. I think everybody knows that the range here is just going to be all reals. Okay, now we got to find the function for this graph. All right, so let's notice what kind of graph it is first. It's starting at the origin and going up, so it's definitely a sine function. So we get y equals something sine there. Okay, now let's look at the amplitude. Looks like we're going up to 9 and then down to -9 there. So amplitude is 9. Now let's find omega here by using the period. So this is probably the critical point here, is to look at this and discover what the period is. So let's see what makes it make a full cycle with this. And so that's not a full cycle because it didn't go to the bottom point. Now there we've made a full cycle, so that would be at 9. So the period there is 9. Now that doesn't mean that we're going to say 9x there, because that's not right. We have to find again, what's that omega value? So remember, the period for the sine function here is what, 2 pi over omega. So the thing is, we know the period is 9, we just don't know what omega is. So we get 2 pi, 9 equal 2 pi over omega, and we cross multiply. We'll get 9 omega equals 2 pi. And so omega would be 2 pi over 9. Now there's no, if you look at where the center line is, the center line was definitely the y-axis there. And so there was no vertical shift. So this would be just 9 times the sine of 2 pi over 9. Okay, next one, we're going to evaluate this. So the inverse tangent of negative square root of 3 over 3. So let's find where tangent is negative square root of 3 over 3. So let me go to the first quadrant and find which one was square root of 3 and which one was square root of 3 over 3. So we'll start right here. I don't have that memorized. So we do sine over cosine. So it would be 1/2 times the reciprocal of square root of 3 over 2. So 2 over square root of 3. And so that gives me 1 over square root of 3. So that would give me square root of 3 over 3. Now let's find out over here. So that would make that negative there. And it would also be negative here. Okay, now recall, inverse tangent here, the domain can only go from negative pi over 2 to pi over 2. And so that leaves that one out. So it's not going to be 5 pi over 6 over here. It would be 11 pi over 6, except for we're going to call that negative pi over 6 here. In the fourth quadrant, we have to name those as negatives with our inverses. Okay, all right, another identity here. This one's probably pretty complicated. So let's start studying the last step. I don't know what the deal is with my pen. It wants to drag everything. Okay, so we got 2 times 1 over cotangent squared is 2 tangent squared. So that makes sense because 1 over cotangent would be tangent, so that one's okay. Now notice this one though, that's not okay. 1 over sine squared there would be cosecant squared. And so that doesn't make any sense. So no choice B. Choice B, you go somewhere else. All right, now let's see, last one, or I'm sorry, choice C. Let's look at the last step here. We've got 1 over secant squared, or 2 times 1 over secant squared is 2 tangent squared. Well, 1 over secant squared is cosine squared. So he's not right either. Okay, let's check this one. I think the choice D has the same thing there as choice A. Okay, so now let's look at first steps. First step's really, really difficult here to figure out. So you need to watch real carefully on this. So on this first step, let's see if we can kind of figure out what's happening. right? Notice that denominator there didn't change anything, so they're doing something to the numerator. Notice they had this minus 1 right there. And so all of a sudden we have that minus 1, and all of a sudden everything's over cosecant squared theta minus 1. They found a common denominator is what's happening there. And so let me show you the work behind that. And you've got to realize what's happening there is that they are finding a common denominator, because this problem had this minus 1 there, and then on the next step they had all of it over cosecant squared minus 1. They found, again, a common denominator. So let's see if they did that correctly. So let's work it out here. So we got 1 plus cosecant squared theta over cosecant squared theta minus 1. And then they had that minus 1 there. Okay, so my common denominator would be cosecant squared minus 1. And so this would just come down. And now we're going to say minus. Now, I went from here to here, so I would have to multiply by cosecant squared minus 1, which would give me cosecant squared minus 1. Okay? Now, notice what they have. They have 1 plus cosecant squared, and then all of a sudden they have minus sine squared minus 1. So I don't know exactly where that came from, but it ain't right. All right, so there goes choice A. So if you'll notice, that's exactly what I had there in choice D. All right, I'm not going to show you the rest of it. That's good. All right, now next one here, we're going to evaluate this. So we're going to find inverse sine of negative square root of 2 over 2, and then find the secant of that. So this is the easy version. The harder version is when you have these reversed here, and these are the same. It kind of gets a little tricky. Now, so let's look for where the sine is negative square root of 2 over 2. So where are you at? Here you go. All right, so at 5 pi over 4 and at 7 pi over 4. Okay, so let's see. Well, we're doing inverse sine here. Well, inverse sine, none of the inverses are in the third quadrant, so not that one. Now, so let's find that 7 pi over 4, or we should call that negative pi over 4. So now let's find the secant of negative pi over 4. So secant would be the reciprocal of cosine. So notice the cosine there is square root of 2 over 2. So the secant would be 2 over square root of 2. We'd rationalize it. We get 2 square roots of 2 over 2, and 2's cancel. So it's just square root of 2. All right. And this one's pretty simple. I probably don't think we need to go over this one. Now this one's just obviously multiplying this out. And so this is a product of two conjugates. So you don't have to FOIL it. You just do first and last. You get 1 minus sine squared theta. And notice that's what that choice has right there when you multiply that out. And that is cosine theta. So that was definitely choice B. All right, next one here, we're doing the secant of negative 5. So I guess we could just punch inverse secant of 5 on our calculator. That's if we had a secant button. So we don't have a secant button, so we're going to have to use cosine. So we would do inverse cosine here of negative 1/5. And that does exist here because this is in between negative 1 and 1. So now inverse cosine of negative 1/5. Oh, darn, I'm in degrees. Hang on. All right, so in radians, it would be about 1.77. Now, I'm going to remind you on this one, just a different problem here. The one that doesn't work out here is inverse cotangent, because inverse cotangent has the same thing here as inverse cosine, where it goes from the first quadrant to the second quadrant. And so if I were doing this instead here, with this being negative, then this would be the inverse tangent of negative 1/5, but then what would happen is it would be in the fourth quadrant, and so I would have to add pi to that. So that's only when you have inverse cotangent and only when it's negative you're going to have to do that. I don't really think that's going to be on our test though, but I just want to be sure y'all know that. All right, let's take a look at this one. All right, very similar to what we've had before. So we're finding out where is cosine 1/2, and then what's the secant there. So let's see, inverse cosine of 1/2. Cosine is 1/2 at pi over 3, and also at, that would be negative pi over 3, but the range of, or domain of, I can't get it right, the range of cosine here is from 0 to pi. So 5 pi over 3 or negative pi over 3, you don't work. Now, so that's pi over 3. So now we just have to find the secant of pi over 3. And recall that the secant here would be the reciprocal of cosine. So the cosine there is 1/2, and so the reciprocal there would just be 2. Really and truly on these, you could take a shortcut. If you notice that these are reciprocals, or they're reciprocal functions, it's just going to be the reciprocal of that. Okay, all right, a little fun one here that we have to factor. So let's substitute here. I'm going to let A equal the cosine of theta. And so this would give me now 6a squared plus 14a plus 8 over 2a squared plus 6a plus 4. Notice you can factor out a common factor of 2 there. Okay, I'm going to do that first, and that would actually cancel them on both of them. So I'm just going to just basically reduce out a 2 here. So that would make that one 4a squared plus 7a plus 4, not 4, but 3 there. And then in my denominator here, a squared plus 3a plus 2. Now let's factor that so we can simplify it. So in the denominator there, factors of 2 that add to give me 3 would be 2 and 1. Okay, I got to split the top one. All right, I'm looking for factors of 12 that add to give me 7 would be 3 and 4. So I'd get 3a squared plus 3a plus 4a plus 4. All right, we could group them here. So we get 3a times a plus 1. And factor out a positive 4, that would be a plus 1 also. So we have a plus 1 over 3a plus 4. Okay, notice now the a plus 1s would cancel out. And so now I have 3a plus 4 over a plus 2. Now recall we said a would be equal to cosine. So this would be 3 cosine theta plus 4 over cosine theta plus 2. Okay, now the graphing one here, I've got to pick the graph. Now, this one's a little bit different. They actually didn't give us any like this, but I think this would probably be okay with you. Notice this one's got a vertical shift, but they didn't put it where we would normally put it. So I'm going to rewrite this. I'm going to rewrite it as y equals -2 times the cosine of 3x plus 6. And so if you see it that way, you maybe see, hey, that's got a vertical shift of 6. So let me sketch my graph. So we're going to shift up to 6. So we go 1, 2, 3, 4, 5, 6. And so there's my center line. And then my amplitude is 2. So I would go up 2 and down 2. There's my amplitude. Okay, now let's figure out maybe what to count by here. So I need to look at the value of the period. So that would be 2 pi. Period is 2 pi over omega, so 2 pi over 3. And so what I'm going to count by here, I'm going to take 2 pi over 3 and divide it by 4. And so that would be 2 pi over 3 times 1/4. And so that would give me pi over 6. I'm going to be counting by pi over 6's here. So pi over 6, I'm going to count it on my center line. So pi over 6, 2 pi over 6 would be pi over 3. 3 pi over 6 would be pi over 2. And then 4 pi over 6 is, well, that's convenient, 2 pi over 3. Now, all right, let's sketch in our graph. So we're going to start, here's our center line there. And so it's a negative cosine. So that means we start down 2 and then go up from there. So this is going to go up to there, and then there, back down to there, and then there. Okay, so I've got one cycle. Now, let's pick the correct graph here. Now, I'm going to throw out actually 2 of them really quick and get the right answer. Wish I'd have noticed this from the beginning. All right, notice that the vertical shift was a positive 6. So that means the cosine curve have shifted up 6. If you notice, these 2 have both shifted downward. So it's got to be this one. And so notice, they did start there where I did. That's actually at 4. And then they went up here. The 6 would be the center line there. And so that's the correct graph.